I'm Elouise and I'm part of the maths team here at the University of Wolverhampton. And this video will be going through graphs. So there's lots of different types of graphs that you might meet in your studies. There's bar charts, histograms, scatter graphs, straight line graphs, and a little category I like to call harder graphs, but hopefully we'll make it not so hard in this video. So bar charts. They show categorical data and they are easy to compare. Okay, so we have our y-axis, it's the one going up like this. We have our x-axis. We need to make sure that we have a title and it needs to be very clearly explaining what the chart is showing. Okay, on the x-axis we have our independent variable. On our y-axis, we have our dependent variable. We also have scatter graphs, which shows the relationship between two variables, or something we like to call correlation. So we can have negative correlation, which is when the graph goes in this direction. So you can see that as temperature increases, the quantity of bees decreases. So that's negative. We have positive correlation, which goes in this direction. So as the temperature increases, the quantity of bees increases. So that's positive. And then we also have no correlation. So if you can't seem to make sense of the graph at all, the points are dotted all over the place and they don't seem to be going in any particular order, it's probably no correlation. Another important type of graph that we come across are histograms, and they're used when the independent variable is continuous, for example, time. So there's no spaces between the bars, and the bars can actually be different widths. Our y-axis is made of frequency density, which sounds kind of scary, but we will go through it in a bit. So if we're drawing, we need to calculate the frequency density from our data first. We do it by dividing the frequency by the group width. So let's say we had this data. It's continuous because it's time, and here are the frequencies. Well, we'll make a column first to see what the group width is. So it goes from 0 to 10, so the group width is 10. From 10 to 15, well, that width is 5. 15 to 30, the width is 15. And from 30 to 40, the width is 10. So that's our first column. Okay? And then we have the frequency, which we were given before. So now, to calculate the frequency density, we go down the list and we calculate the frequency by the width. So for our first column, for our first bar, 0 to 10, we have a frequency of 14 and a width of 10. So 14 divided by 10, 1.4. And that would be our frequency density that goes on the y-axis. Straight line graphs. So straight line graphs have the equation y equals mx plus c, where m is the gradient. It can be any number at all, a whole number, a negative number, decimal, a fraction, a surd. It can be anything you want, but it determines the steepness of the line. And the c is the y-intercept, which means where it cuts the y-axis. So if we had 2 points and we wanted to find the gradient, we could find the change in y and divide it by the change in x. So let's have a look at these 2 points. We have points 2 and 3, and I'll say that's our x-coordinate number 1 and our y-coordinate number 1. And we have 5 and 7, and I'll say that's the x-coordinate 2 and y-coordinate 2. So to find the change, we do m equals y2 minus y1, because that's how we calculate the difference between two numbers. And we divide it by x2 minus x1. Again, we're calculating the difference between the two numbers. So our y2, as we've labelled here, is 7. Our y1 is 3. So our top line is 7 minus 3. Our x2 is 5 and our x1 is 2. So our bottom line is 5 minus 2. And when you plug that into a calculator, you get 4/3. So that is the gradient. If you didn't want to do it this way and you wanted to do it for a graph, you could just look at the points. So if you see the change in x we can see goes across 3. And we can see that the change in y goes up 4. So the difference is 4 and 3. So 4/3. But you do need to be careful when doing this way that you're making sure that it's positive or negative depending on whether the graph is positive or negative. So how about if we wanted to find the equation of a line? Well, let's find two easy to read points first and calculate the gradient from that. So these are the 2 points I'm going to use because it cuts the axis clearly at 3 and 0. So that's a nice easy to read one. And then again, this next one at -1 and 1 cuts it perfectly. So we know it's not -1.5 or a little bit to the side. It's very clearly -1 and 1. So we found our 2 points now, and we label them x1 and y1 and x2 and y2 as we did earlier. And we calculate the difference. And just to make sure that you're getting your negatives involved here, so we've got a 0 minus -1, which makes it a positive 1. So make sure you're not losing any negatives here. And then we need to find the y-intercept. Well, where does this line cross the y-axis? It crosses it at 3. And it crosses it at +3, which means that when we put it all into the equation, we get y equals 2x plus 3, because our gradient was 2 and our intercept was 3. So here are some harder kind of graphs that we might meet. Quadratics, cubics, exponentials, reciprocals, and circles. Now, quadratics has a video all in itself, so you can go and watch that if you want to find out more. But I'm going to be going through a quick whistle-stop tour of the others. So, cubics tend to look like this. They'll have an x cubed term, which is why it's called a cubic. And to graph them, we tend to factorize them into 3 brackets, and that will help us find where it cuts the x-axis. Exponentials look like this. So it's y equals k to the power of x, where k is any positive number. So it could be 5 to the power of x. It could be 10 to the power of x. Exponentials always go through 0, 1, because anything to the power of 0 is 1. And this is what it looks like when it's positive x, and this is what it looks like when it's negative x. So reciprocals come in the form xy equals k. Now you're probably used to seeing equations in the form y equals, but you can easily rearrange this into y equals k divided by x. Properties of reciprocals are that they're undefined at x equals 0 and y equals 0. So they never touch but get infinitely close to the axes. So as you can see here, the y-axis and the x-axis are asymptotes, which is a word that you might need to know when you come for your studies. And it just means that it will get closer and closer and closer to that line, but it will never ever touch it. And circles. So circles come in a formula of x minus a all squared plus y minus b all squared equals r squared, where the centre of the circle is at coordinates a and b, and the r is the radius of that circle. So that's it for Graphs 101. Hopefully you found it useful, and please make sure to check out any other maths videos.